Let's try to understand the difference between decision tree and random forest. Consider this dataset where you have three types of data points: apple, cherry, and oak. On x-axis, you have the diameter of these trees. On y-axis, you have the height. So the points indicate that the trees with lowest diameter and lowest size belong to cherry, and the ones generally with biggest diameter is like an oak. And we can construct a decision tree to make this prediction saying, okay, if diameter is greater than certain number, it will be oak. If it is less than, it may belong to cherry or apple. And then you have to use the feature which is height also. Like that, you can construct a decision tree with certain number of branches. Now, the problem with decision tree is that it is so sensitive to the input data. So here, check this perturbed sample 1. What you can see here is the input data is changed by only 5%. So this input data which you see in this graph is 95% similar to the graph you see above. And that results in a decision tree structure which looks like this. So there are two branches from the first main node, then the left-hand side node is again split, then this node is again split into two. So you can see that there is a certain depth to this tree. There are a certain number of branches. You can see where the final nodes are ending on the leaf, etc. But the more interesting thing is if you look at this perturbed sample 4, you can see that just by changing another 5% of the data set, so the difference between these two data is only 5%, and you can see that the structure of this tree is entirely different. So what this shows is to get a certain degree of classification accuracy, the tree is so sensitive to the input data that it may not be generalizing the general patterns in the data. It's also very sensitive to the noise, which is why 5% perturbation is affecting the tree structure so much. So what is random forest? Random forest solves this problem by considering a collection of decision trees. So the name forest in random forest means it's a collection of decision trees, just like how trees construct a forest. So here, the word random also has a meaning. It means you are randomly sampling data from the training data to train individual decision trees. So these decision trees are seeing different subsets of input data, and each tree will make slightly different prediction. Now, if the prediction is supposed to be binary, so here you can see three trees. First tree is saying the prediction is no, second is yes, third is yes, which means majority of the trees are saying the prediction should be yes. And based on this majority voting, the final output prediction will be yes. Otherwise, it will be no. So random forest simply takes a majority voting of all the trees that are part of the forest to make a prediction. And this has lesser sensitivity to noise because each tree is anyway seeing perturbed sample.